Thank you. Welcome. Again, thank you to Assini and thank you to EFI for giving me one more opportunity to get myself and my project to you. ESP32 is a project which is on the verge of being a SDR, software defined radio. You will find that nowadays that software has changed many things of us, many things around us, and software radio is one that in that kind. This is not in true sense a software defined radio, but in many ways it does everything other than this modulation and demodulation part, which is normally done through a software defined radio. Nevertheless, the microprocessor does the same work. I'll share a small presentation first. Through that presentation, I will describe you the intricacies and what is the crux of this whole project. And after that, if time permits, we'll take up a few question and answer sessions. Well, I'm S. Bera. Have been connected with EFI for around 6 years, and I have more than 100 DIY project appeared all over the world. And ESP32 being one of the most popular project of mine. After this project appeared in EFI, it then appeared in many formats all around the world. A lot of modification, upgradations have been done in these projects. So welcome to you. This ESP32 radio. And I always dedicate my session to my mom, who was an avid reader of my projects. And I dedicate this session to my mom. Okay, then coming to the next slide. There are thousands of radio stations operating in internet. You can jolly well tune any of those websites in your computer browser, and you can listen to those radio stations. But for that, you need to have a multimedia computer with internet connections. That's what is you only require. But should we really devote one full computer for making a internet radio? Having a screen, having a CPU, having a power supply unit, and all those things. Because the same fit can be achieved by ESP32, which is a not more than $4 microcontroller unit, and having a moderate speed of 160 megahertz clock speed. And another item required for this radio is an MP3 decoder, and of course a pair of earphones. So that's ESP32 SDR for you. You need only one ESP32 or a better microprocessor. ESP8266 can also work, but I discard 8266 because I found that it hangs because it cannot handle 32-byte audio one at a time. So it may work, it may not work, but I discard 8266. It has a bigger form factor also, whereas ESP32 is a very smaller one, and capacity wise it is much bigger than ESP8266. When I developed this project around 3 years back, there was allegedly a few C code was available and the Python code was available, but those are huge code, almost 200 to 250 lines long, and there was none on Arduino. And 3 years back, this fast decoder came into the market, VS1053 or 1000. It can decode many music formats, including these aux, Vorvis, AAC, WMA, Wave, and MIDI, and of course MP3. Okay, the trick lies is that ESP32 is a good microcontroller unit, but it cannot stream the data continuously. If you just open the input channel at one end of the MCU and take the audio out through the other end of the decoder. So the trick is that you have to feed only that much data which the ESP32 can take up. And the trick is that an ESP32 can take up 32-byte data. 32-byte data at a time, it can process it and it can play it back through the decoder. So the thing is that if you, in the ESP32, if you will connect it to the internet using its internal 2.4 gigahertz capacity Wi-Fi, and you will connect to that radio station, and the data, whatever audio data appears on the output of that browser page, will collect 32 byte at a time and feed it to the ESP32, and ESP32 plays it back, and before the 32 byte data finishes up, you supply the another chunk. So in other way, you are giving it packets 32 bytes long and continuously feeding. So in a way, you are continuously feeding the ESP32, and ESP32 is producing the output. So that's the trick of this whole project. If you understand that trick, then a 15 lines Arduino code is enough for the radio station to play. So I'll show you that 15 line code. You will understand it better. But right now, I understand that that was the trick of this radio. ESP32 is a powerful MCU, dual core, 160 megahertz. It has got two cores. Having two cores got its own advantages. It has a very good power down mode. It can have a deep sleep mode at the same time. It can wake up again from the deep sleep, because one module will be monitoring the time, whether the remaining part of the module will go to sleep mode. So that's the advantage of having dual core. And VS1053, you know, it's a decoder. It's plenty available in the market. It will has to play the data which comes out of ESP32, and ESP32 maintain that internet connection, and the process continues. So in a way, you are supplying packets after packets to the ESP32, and ESP32 is paying it packets after packets. Well, this is the bare minimum prototype which I made at the beginning. This VS1053 is a 5-volt device. It takes 5-volt input, and ESP32 is a 3.3 volt input. So what I did that, I jigged that VS1053. I simply sorted that 5-volt input to 3.3 volt regulator input. I'll show you. So it becomes a 3.3 volt input supply. That's what I have received from the ESP32. On the left of that red line, if you see, that white line is the 3.3 volt goes to the VS1052. And here in this red circle is nothing but a make shift switch. That's a push to on switch, you can say. If you push one time, it will shift to the next radio station and next radio station. In a way, it goes. And in the program, I'll show you. In between the stations, you have to do a soft reset to the ESP32, so that it goes to the next station. Otherwise, the memory retains. And this is the ESP32 radio running on 3.3 volt, taking from the power from the USB. And I have added one OLED. This is simple. It goes to the I2C connection. You can have it, or you may not have it. It is not. It is absolutely optional. This is the full project. Of course, later I housed it in a small container, and instead of using that ESP32 development board, I use that bare minimum chip. So it becomes much smaller in size. This is 1053. I jigged it for making it a 3.3 volt line input. This is simple. Those who knows how a regulator, 3-pin regulator works, is that there are two regulators. One is a 5-volt regulator. One is that 3.3 volt regulator. So V in is capable of this 5-volt. It goes to 3.3 volt. So 3 volt straight away you can take it off. Okay, it's not a very big job. Anyone of you can do it, who understand these regulators. These are although it is showing 4 legs, but those are actually 3 legs. The middle pin and the heatsink pin, they're same pin. This is the schematic. This is the schematic. In the VS1053, you will find a number of pins are there. You have to get those pins connected absolutely with the correct numbers. Rather, I'll go to the EFI picture that's more clear. Yes, this is the EFI picture. It is there in EFI site. These are the pins in this decoder, and you have to get those pins properly connected. See this MISO, MOSI clock. These are the fixed pins. These are 18, 19, and 23. These are fixed pins. You cannot mess them up. And the other pins, REG, CS, and XDCCS, and XRST. XRST is a fixed pin going to EN, and the remaining 3 pins you can have your choice. You have to mention them in the invoking of the VS1053 call, which is done normally in the setup. And the OLED, it goes to I2C. These are the I2C pins of 21, 22. You also have a choice here. You can go to other pins also. And this is a push to on switch because it's a battery operated device. So here I always prefer this regulator, HT7331. HT7331 has a distinct advantage of very low loss factor. Even if the 3.7 volt LiPo normally goes up to 4.1 volt. When it becomes fully charged, it goes to 4.1 volt. So 4.1 volt, if you connect to the VS1053, ESP32 may withstand, but VS1053 is very sophisticated. So beyond 3.3 volt, it will simply burn out. But through this regulator, you can ensure 3.3 volt supply. And if the voltage becomes 3.8 or 3.85 even, then also it will be able to provide 3.3 volt. The loss is very less. So that's the advantage of this regulator. This is again a 3-pin, looks same like H1117, that 3.3 volt regulator. So not the same thing, but it has got advantages. So this is the regulator it is used, or if you use it from a ESP32 development board, there you can get 3.3 volt from the board itself. And yes, these are the radio stations, typical radio stations. There are thousands of radio stations available in internet. If you just supply these URLs to your internet browser, they'll play the same music which you will be getting through ESP32 radio station, radio project. The only thing is that you are getting rid of having a big computer. Even those who have come across the Beatles. So Beatles have a couple of radio stations in UK, and that George Ringo, that Michael George also has a radio station in his name. Then that John Lennon, his wife Yoko Ono, he also has a radio station in the name of John Lennon. There's a lot of radio stations are there, and seeing those listening to those radio stations, it's a big pleasure, because those are absolutely stereophonic sounds are there, and good quality sounds are there also. So that's about the ESP32, those stations where you have to tune in. And of course, ever since this project appeared in national and international magazines, and the Arduino codecs have been modified to suit many tastes, many choices all over the world. Just search ESP32 internet radio and you'll come to many such varieties and formats, and many formats you'll find my name also. So that was all about the presentation. And now I'll come to show you that tricks I have used in that Arduino code. Then we'll go back to this ESP32 radio sites hosted by EFY. Well, friends, the top portion, I have just mentioned those radio stations URLs. This is the 1053 connections I have written here. And well, the code starts from here. This is the library file for VS1053 codec. Well, the preference.h, this is again optional. This is optional because this I have used for using the ROM memory of ESP32. Just imagine you have stopped that radio at a particular station A, and if you open up, you want your radio station to operate from for radio station A. So what it will do, it will go back to that radio station A, and that the reference to the station A will come from this program preference.h. After opening the ESP32, it goes to the memory locations of preference.h program. It will open up what is there, and also it can be used for tuning to which internet connection to connect in. So that also you can go back there. So a lot of choices you can make here using preference.h. Same way you can keep the volume in memory. I have used one internet connection here, but nowadays you can supply many internet ID and passwords in the ESP32, and ESP32 has a beautiful search option. It will find out and it will go to the all those network connections, and whichever gets connected, it will go there. It will get connected with that one, the first one. So you need not to put logic here. So that is now possible. Tomorrow I have a session, and there I'll show you. There I use that feature because this is a very old project. So that time this feature was not available. Otherwise, you will supply all your internet authorization passwords here, and ESP32 will find the suitable one on its own. Those radio stations, those path and the port, all I have put in 3 arrays. And there is one more array I have used, that station name. This will appear on the OLED screen. And this 13 I used for what is that, the change button, station changing button. Okay, let's go to the trick which I have used. These are the pin I have defined. You can straight away use those pins here instead of mentioning separately here. You can straight away 32, 33, 35 here, and it will still work. So these many numbers lines will be reduced. So literally these lines, these 5 lines will be reduced to 1 line. Well, these are for the display, which is certainly optional. This display, this whole part is optional. You can have it, you may not have it. So this lines is also redundant. 1, 2, 3, 4, 5, 6, 7 lines. So 7 and those 5 lines, 12 lines is redundant here. These are the comments, guys. These are the comments. These are not required at all. Just to make you understood, I have written down here. Well, this is the player is beginning. You are initializing the decoder. You are setting the volume to volume. Volume is a variable there. It mentioned on the top. It's 80% or 70%, whatever it is. We are connecting the Wi-Fi. So these are the serial printing. You can get rid of them eventually. Wi-Fi connected, IP address, and all those things. And well, here we are forming the station. Station we are forming in the form of a string x1. See, all those variables are getting into connected to and defined by x1. Again, this is drawstring. ये आपका OLED screen में print कर देगा. And then this is the preference model we are using. We are going to the beginning. At the beginning, we are going to the memory location, 0 location of ESP32, and we are finding out what is written there. The last station name will be written there. That's all. And we used a variable here. We have used a function somewhere. See, I have given a help file. This is a help audio file is available here. Those are byte strings are all mentioned here. Just leave it as it is. You can use it, you may not use it. This will just give you an idea whether the decoder is working or not. This line will play the code mentioned is hello mp3h. It will say a few preliminary words to indicate you that your decoder is working perfectly. And now we are connecting the radio station. This station connect counter. Well, now what is the counter is there? Let's see. This is the counter. What it is doing? It is going to the website, going to the particular port, and it is getting the data. Get is nothing but after writing that URL on the browser window, you just press that enter button. So that's get. So the output is coming up. Okay. Now what it is doing with this output? The most important function is here. See, this is the radio. Actually, this is the radio. If the client available is greater than 0, it read the output, put it in MP3 buffer, only 32 byte at a time. That's it. This is the radio. And then it is giving to the player to read it. And this thing will continue. So literally, this is the trick which has opened up this possibility that ESP32 can be as a radio station. The remaining things are all, if you see here, this will just change the radio station. So that was all about this code. And the remaining code is all the display and all those non-essential things. You can straight away get rid of those things. And now I'll stop this sharing and I'll go to EFI site. This is what is appearing there in internet in EFI. Well, EFI has clocked more than 35,500 viewers for this project, and some of the comments are very beautiful here, and they have rightly attributed this thing that this is really is the easiest one. One is Mr. Charlie. Then someone found that his stereo was not working. Ultimately, when he changed that codec decoder, then he found that it was working. So those are the comments. I really appreciate that, because that was the crux of this whole project. It's the easiest one. Well, now I'll open the floor for questions. There are some questions have appeared. Once you understand this this functionality of this radio, you can make it next. You can elevate it to the next level where you can really deploy it for software-defined radio. In the software-defined radio, what you actually understand, what it does actually, it gets the raw signals from the atmosphere, including that satellite signals, and they modulate it through antenna. They receive signals, then they modulate it, and they take the audio or video or the data part out of it. So there also the MCU will do additional modulation and demodulation part. So it is again done with this microcontrollers. Thank you.